Welcome. Today we will learn how we can turn on a contactor with the PLC and how we can do the programming in the PLC to properly turn on and off the contactors. Before starting, I would request you guys to please subscribe to my channel to stay connected with me and press the bell icon to get the notification of the newly uploaded video tutorials. First, let's discuss the setup for the today's tutorial. We have installed here a motor protector breaker and 3-phase power lines are connected at the input terminals of the motor protector breaker. Next we have a 3-phase contactor with a normal open auxiliary contact. The coil of the contactor is 24 volt DC. Next we have two push buttons. The green push button is normal open contact push button and the red push button is also a normal open contact push button. Next we have a PLC here. We will be programming to control the inputs and the output logics. So this is the setup for the today's tutorial. We will see how we can use the push buttons to turn on and off the motor and how we can detect the tripping of the motor protector and the malfunctioning of the contactor, and how we can make logics in the programming to generate alarm bits in the case of tripping of the motor protector. Now let's see our wiring configuration for the inputs and the outputs which are connected to the PLC. First, the green push button is connected at I0.0 input of the PLC. We can call this push button as start push button. Next, we have connected the red push button at the I0.1 input, and we can call this push button as stop push button. Next, we have connected normal close auxiliary contact signal of the motor protector breaker to the I0.2 terminal of the PLC. As this contact is normal close, the input I0.2 will go low if the motor protector breaker trips because of the motor overload current. Next, we have connected normal open auxiliary contact of the 3-phase contactor at I0.3 input terminal of the PLC. This input signal will confirm that the contactor has turned on. Now let's discuss the programming. The network 1 is programmed to start and stop the motor contactor. We put here the normal open contact of the input I0.0 start push button in series directly with the output coil Q0.0 contactor. So when we press the start push button once, it will latch on the contactor Q0.0 and it will stay on even if we release the start push button, because when the Q0.0 turns on, its normal open contact Q0.0 closes and it will complete the logic path and Q0.0 will stay latched on. Now you can see that we have used here the normal close contact of the start push button I0.1. If we press the start push button once, this contact will open up and it will break the logic path and this will turn off the output Q0.0. Next, we will insert the normal open contact I0.2 of the motor protector auxiliary contact in series with the output Q0.0, so that if the motor protector gets stripped because of the motor overload, this contact will get opened up and output Q0.0 will get unlatched and turns off. Network 2 is programmed to detect the contactor malfunction. We insert here the normal open contact of the contactor Q0.0 bit in series with the normal close contact I0.3 of the contactor. If the PLC turns on the contactor Q0.0 but the contactor cannot turn on because of the malfunctioning, then this normal close contact I0.3 remains closed. And this will start the 1-second safety timer, and once the timer is over, it will turn on M10.0 contactor malfunction bit. We can use this bit in the network 1. We can insert this bit as a normal close contact in series with the output Q0.0, so that if the alarm bit goes high, it will unlatch the contactor Q0.0. Network 3 is to generate the alarm buzzer if the motor protector tripping or the contactor malfunctions. We will keep this simple and we will modify later in this video. Let's go online with the PLC and now start the PLC program testing. If we press the start push button, it will turn on the contactor Q0.0, and once it is turned on, its normal open contact also gets closed, and this latched on the Q0.0 contactor. Now if we press the stop push button I0.1, this will break the logic path and turn off the contactor Q0.0. Now let's turn on again the motor contactor Q0.0 by pressing the green push button. The Q0.0 contactor gets latched on and motor starts to run. Now if the motor gets overcurrent, maybe due to mechanical shaft load, the motor protector gets overloaded and it suddenly trips, and the normal open contact of I0.2 of the motor protector gets opened. This will unlatch the output Q0.0 for the motor contactor. In network 3 normal close I0.2 motor protector contact bit will turn on alarm buzzer M10.1 bit. Now we will test the network 2 programming to test the contactor malfunction. In the network 3, I have increased the timer preset value from 1 second to 10 seconds so that we could have time to see how the logic is working. Now let's turn on the contactor Q0.0 by pressing the green push button. As you can see that the Q0.0 output is high, but the contactor is not physically turned on, maybe its coil is not working. Because the contactor is not on, its auxiliary contact I0.3 remains closed in the network 2. This will start the safety timer. Once the timer is over, the contactor malfunction M10.0 bit goes high and this same bit gets opened for a moment in the network 1 and turn off the contactor Q0.0. In the network 3, alarm buzzer bit gets latched on and this will stay on until we toggle the alarm reset bit M10.2. So this is how we can program a ladder logic to turn on a contactor and related alarms. I hope you liked today's video. Please share, like and subscribe. Till next time, take care and goodbye.